Quantum physics intertwines the very fabric of reality, challenging us to rethink the everyday and the extraordinary.
Imagine waking up to a world where the invisible forces of nature aren't just the stuff of science fiction, but a reality that shapes everything around us, from the glow of your morning toast to the blazing speed of your smartphone. This isn't the realm of the distant future or the exclusive domain of scientists in lab coats. This is the world of quantum physics, a fascinating field that might sound complex and unreachable, yet it's influencing your life at this very moment. Quantum physics, often seen as a challenging topic reserved for geniuses, is actually at work all around us in ways we might never realize. But what if I told you that this mysterious science is the backbone of many everyday technologies? That it shaped the reality you live in every single day? Did you know that quantum physics is influencing your reality right now? Let's explore how this incredible science is not just a part of the universe, but a part of your very existence. Quantum physics may sound like a concept pulled straight out of a science fiction novel, but it's a real and vibrant part of our everyday lives. This fascinating branch of science explores the smallest particles in the universe, elements that aren't just tiny, they're practically incomprehensible in their behavior and their capabilities. These fundamental particles, such as electrons and photons, do not follow the classical laws of physics we're used to. They dance to a tune of their own, existing in states that defy straightforward explanation. At the core of quantum physics are a few mind-bending principles that seem to challenge the very nature of reality. One of these is the idea of superposition. Picture a coin spinning in the air. It's not just heads or tails, it can be both at the same time, at least until you catch it. In the quantum world, particles can exist in multiple states simultaneously, just like that spinning coin, providing the foundation for phenomena that power our technologies and shape our understanding of the universe. Another intriguing aspect is the principle of entanglement, which Albert Einstein famously referred to as spooky action at a distance. This occurs when pairs or groups of particles interact in ways such that the state of one particle cannot be described independently of the others, even when they are separated by large distances. This interconnection persists no matter how far apart they are, suggesting that information can be transferred instantaneously. Wave-particle duality is yet another fascinating concept. It reveals that quantum entities can exhibit both particle-like and wave-like behaviors depending on the experimental setup. This duality is crucial for understanding how light and matter behave under different conditions. Now let's translate these abstract principles into everyday life. Starting with your morning routine, when you toast bread, you're witnessing quantum physics in action. The red glow of the toaster's heating elements comes from electrons getting excited and releasing photons, a quantum event. Quantum physics explains why these photons emit just the right kind of light to heat your delicious breakfast without emitting dangerous radiation like X-rays. Moving on to your workday, every time you use a computer, you're relying on quantum physics. The semiconductors in your computer's chips work because of our understanding of quantum mechanics. Electrons move through these materials in ways that classical physics couldn't predict alone. Without quantum mechanics, the precise behavior of these particles, and hence the very operation of these chips, would be impossible to manage. Then consider the lights that brighten your office or home. Fluorescent bulbs are a common sight, and they owe their efficiency to quantum mechanics. Inside each bulb, electricity excites mercury vapor, which in turn emits ultraviolet light. This light is then transformed into visible light by a phosphor coating inside the bulb, another quantum process, where materials absorb and re-emit light at different wavelengths. Each of these examples, your toaster, computer, and light bulbs, might seem mundane, but they're all demonstrations of quantum physics at work. This science isn't just about theoretical experiments and complex equations. It's about the fundamental processes that animate everything in our universe, from the light we depend on to see to the technologies that keep us connected. In explaining how everyday objects utilize quantum physics, we can see that this field isn't just for academics in ivory towers. It's a vital part of the fabric of modern life. Each example shows how deeply integrated and essential quantum physics is, not just in specialized laboratories, but in our everyday experiences and the devices we use without a second thought. Through understanding quantum physics, we gain more than insights into the universe. We harness its laws to innovate and improve our technology, pushing the boundaries of what's possible. It's a perfect illustration of how deep theoretical knowledge translates into practical applications that benefit everyone, everywhere, every day. As we continue to explore and understand these quantum principles, we push the envelope on what technology can achieve and how we perceive the world around us. Quantum physics is not just shaping the future, it is the vibrant, dynamic force that molds our present reality, making the impossible possible and turning the unimaginable into the everyday. Quantum mechanics isn't just a theory tucked away in textbooks, it's a powerhouse driving major technological revolutions that transform how we live and work. One of the most striking examples of quantum theory in action is in the field of computing. The development of the transistor, the backbone of all modern electronics, was possible only through a deep understanding of quantum mechanics. This small device, which flips on and off to perform logical operations, harnesses the behavior of electrons at the quantum level to process every piece of digital information. From the smartphones in our pockets to the vast servers that power the internet, every piece of digital technology owes its existence to the principles of quantum mechanics. It's the strange, counterintuitive behavior of quantum particles that allows us to develop smaller, faster, and more efficient devices. As we push the limits of what traditional materials like silicon can achieve, quantum mechanics guides researchers in developing the next generation of technology, potentially using quantum bits or qubits, which can exist in multiple states simultaneously, offering unprecedented processing power. Moreover, the emerging field of quantum computing promises to revolutionize industries by solving problems that are currently beyond the reach of classical computers. Quantum computers could optimize complex systems like traffic flows in megacities, or make financial markets more predictive. They might also unlock new frontiers in artificial intelligence by processing vast amounts of data at speeds unattainable today. Shifting focus from silicon to health, quantum mechanics plays a vital role in medical imaging technologies. Techniques such as magnetic resonance imaging, MRI, rely on quantum properties to visualize the inside of the human body with astonishing clarity. MRI scanners use powerful magnets and radio waves to map out the water molecules in human tissue. The alignment of these molecules, influenced by quantum effects, provides detailed images that are crucial for diagnosing a wide range of conditions. The precision of quantum mechanics doesn't just stop at diagnosis. It extends into the realm of treatment, where researchers are exploring quantum dots for targeted drug delivery. These tiny particles can navigate through the body to deliver drugs directly to disseminated cells, potentially increasing the efficacy of treatments while minimizing side effects. The impact of quantum mechanics on health extends even further into the future. Researchers are investigating how quantum effects could play a role in understanding and perhaps curing diseases at a molecular level. By manipulating quantum states in the cells, scientists may one day be able to reprogram or correct faulty genetic sequences that lead to disease. Quantum technology also offers promising advances in the field of medical sensors. These devices could be capable of detecting the smallest changes at the cellular level, providing early warnings for conditions like cancer long before conventional methods would catch them. Looking ahead, the integration of quantum mechanics with biology could lead to a new era of medical technology. Imagine a world where quantum sensors detect health changes almost instantly, or where quantum effects are used to create new types of treatments that are incredibly precise and personalized. These possibilities are not just theoretical, they are the next steps in a journey that has already begun, thanks to the foundational theories of quantum mechanics. As we continue to unravel the complex behaviors of particles at the smallest scales, we open up new pathways for innovation that could reshape the landscape of technology and healthcare. Every advancement in technology and every breakthrough in healthcare powered by quantum mechanics is a testament to the profound impact this deep understanding of nature has on our world. It illustrates that by probing the mysteries of the quantum realm, we are not just expanding our knowledge, but actively building a better, more technologically advanced future. As we stand on the brink of these exciting developments, it's clear that quantum mechanics is not just an academic curiosity. It's a vital tool in our ongoing quest to improve human life through technology. The quantum world may be small, but its potential to drive big changes in technology and health is limitless. With each quantum leap forward, we are not only witnessing science fiction turn into science fact, but are also taking part in shaping a future where the full spectrum of quantum possibilities becomes a part of everyday life. The natural world is a canvas of incredible complexity and beauty, where quantum mechanics plays a subtle yet profound role in phenomena we observe every day but might not typically associate with physics. Take, for example, the process of photosynthesis. This fundamental process, which plants use to convert sunlight into energy, is not just a marvel of biological evolution, but also a quantum phenomenon. Within the heart of every green leaf, light particles, photons, are captured, and their energy is transported with exquisite efficiency. Scientists have discovered that this energy transfer occurs through a quantum mechanism called coherence. In simple terms, energy is transferred through multiple pathways simultaneously, a feat that enhances efficiency and is still not completely understood. This quantum process ensures that plants absorb sunlight with near-perfect efficiency, which challenges our conventional understanding of energy transfer. It's a stunning reminder of how quantum mechanics is intricately woven into the very fabric of life. Beyond the leaves of plants, quantum processes are also believed to play a role in the remarkable navigational abilities of birds. Researchers have been fascinated by how migratory birds can travel thousands of miles with astonishing precision. Studies suggest that birds may be using a quantum compass to sense the Earth's magnetic field, guiding their migrations. This compass might involve a quantum phenomenon known as entanglement in a protein within the bird's eyes. The entangled states in these proteins could be influenced by the magnetic field, providing birds with the directional information they need. These examples from nature are not merely quirks or oddities. They represent the cutting edge of our understanding of the natural world, challenging us to think about biological processes not just as chemical reactions, but as quantum mechanical interactions. The implications extend beyond biology, suggesting new ways to harness energy, improve navigation systems, or even develop new technologies that mimic these natural processes. Quantum mechanics in nature provides a compelling illustration of how the universe operates on principles that are fundamentally different from our everyday experiences. It invites us to reconsider how we perceive the natural world, encouraging us to think about the deeper connections between the living world and the laws of physics. The exploration of quantum biology not only expands our understanding of nature, but also enriches our appreciation for the complexity and elegance of the systems that sustain life on Earth. As we continue to explore these quantum biological processes, we are not just uncovering the secrets of nature, we are also opening doors to potential new technologies that could transform our approach to energy, medicine, and electronics. Nature, in its wisdom, has been using quantum mechanics all along. It's time for us to catch up. Quantum physics, a realm traditionally viewed through the lens of hard science and mathematics, may also hold the key to understanding the more elusive mysteries of human perception and consciousness. As we dive into the interconnections between quantum mechanics and the human mind, we uncover intriguing possibilities that suggest our brains might operate on principles that extend beyond classical physics. One of the most fascinating aspects of this exploration is the theory that quantum processes could be at the heart of cognitive functions. This idea stems from the hypothesis that quantum states, including superposition and entanglement, might influence how neurons in our brains interact. Unlike traditional views that see neural activity as purely biochemical, this quantum perspective suggests a layer of complexity where thoughts and decisions could arise from quantum states in molecular structures within our neurons. Consider for a moment the phenomenon of superposition, where a quantum system can exist in multiple states simultaneously. Applied to neural processes, this could mean that our brains are capable of holding overlapping thoughts and emotions until a particular observation or decision collapses these possibilities into one outcome. This could potentially explain the rapid and often subconscious processing that underpins intuition and snap judgments. Entanglement further enriches this discussion. If parts of the brain are entangled at the quantum level, It could allow for the instantaneous correlation of information across different areas of the brain, surpassing the limits of classical signal transmission. This might illuminate how complex, synchronized activities, like the simultaneous processing of disparate sensory inputs, occur almost instantaneously. Moreover, the theory of quantum consciousness proposes that our subjective experiences, the qualia of consciousness, are deeply rooted in the quantum interactions within our brains. This theory ventures into the profound question of what consciousness itself might be, not just a byproduct of complex computations, but a fundamentally quantum phenomenon. The implications of such theories are profound. They suggest a new way of understanding mental phenomena such as creativity, memory, and perhaps even the enigmatic nature of dreams. By viewing these processes through the quantum lens, we might find explanations for cognitive functions that traditional neuroscience has struggled to fully explain. This perspective also prompts a reevaluation of how we perceive reality itself. If our consciousness is intertwined with quantum mechanics, then the very act of perception could be a creative process, shaping as much as it observes the world around us. This aligns with the observer effect in quantum mechanics, where the act of observation can determine the state of a quantum system. Exploring the quantum foundations of perception and consciousness not only broadens our understanding of the mind, but also offers exciting possibilities for bridging the physical sciences with psychology and philosophy. As we continue to unravel these connections, we may find that the structure of reality and our place within it are far more intertwined and dynamic than we ever imagined. In this quest, the study of quantum brain dynamics is not merely an academic pursuit. It is a journey toward understanding the very essence of human experience and interaction with the world. The more we learn about the quantum underpinnings of perception and consciousness, the closer we get to unraveling the complexities of the human mind, a frontier as vast and mysterious as the universe itself. Quantum physics has captured the imagination of filmmakers, writers, and media creators, often serving as the magical ingredient in narratives that challenge our perceptions of reality and possibility. From blockbuster movies to best-selling novels, the concepts of quantum mechanics are frequently used to weave stories that are both captivating and mind-bending. However, as we journey through these fictional worlds, it becomes crucial to discern the line between scientific fact and creative liberty. In the world of cinema and television, quantum physics often plays the role of a plot enabler that allows characters to leap across time dimensions or solve unsolvable problems with unprecedented ease. Films like Interstellar and series like Stranger Things use quantum mechanics to explore parallel universes and time travel, while the quantum realm itself becomes a central plot point in superhero narratives like Ant-Man. These stories intrigue audiences with their complex, layered realities and the tantalizing possibility that there might be more to the universe than meets the eye. While these portrayals help bring difficult, scientific concepts into the public eye, they also give rise to significant misconceptions. One of the most common misunderstandings is the idea that quantum mechanics allows for any kind of supernatural phenomenon, or that it can be used to justify inexplicable events at a whim. In reality, while quantum physics does challenge our classical views of reality, it does so within very specific and well-understood parameters that scientists can test and validate. Moreover, popular culture often suggests that manipulating quantum phenomena is a straightforward task that can be achieved with simple gadgets or sheer willpower. This depiction overlooks the intricate and delicate nature of quantum experiments, which require highly controlled environments and advanced technology to even observe, let alone manipulate. Another prevalent myth is the conflation of quantum mechanics with the observer effect, suggesting that merely observing an event can alter its outcome. While the observer effect is a real phenomenon in quantum mechanics, it does not imply that human consciousness can directly influence material reality just by the act of observation. The actual science involves changes in the physical state of a quantum system due to the interaction with measuring instruments, not the mere presence of a human observer. Despite these embellishments, the inclusion of quantum physics in popular media has a significant positive aspect. It inspires curiosity and wonder about the natural world. It encourages audiences to ponder deep questions about the nature of reality, existence, and our understanding of the universe. These narratives push the boundaries of conventional thought and invite viewers to think critically about the difference between science fiction and science fact. By engaging with these portrayals critically, we can appreciate them for their creativity and storytelling prowess, while also pursuing a clearer and more accurate understanding of what quantum physics entails. This dual approach allows us to enjoy the thrills of fantastical narratives without losing sight of the rigorous science that makes quantum mechanics so endlessly fascinating in the first place. Quantum mechanics is not merely a collection of equations or experimental outcomes. It is a profound inquiry into the nature of reality itself. As we explore deeper into the quantum world, we find ourselves confronted with philosophical questions that challenge our basic assumptions about existence and our role within the universe. This branch of physics, perhaps more than any other, blurs the lines between what is known and the great mysteries that remain. The implications of quantum mechanics extend far beyond the laboratories where particles are smashed and observed. They reach into the realms of philosophy, where scholars have long debated the nature of reality and our ability to perceive it accurately. Quantum physics introduces a startling element to these discussions: the idea that at the fundamental level, particles exist in multiple states simultaneously until they are observed. This phenomenon, known as superposition, raises the intriguing possibility that reality is not fixed until it is measured, and thus, observation itself may shape the outcome of events. This leads us to ponder the observer effect, a concept at the heart of many quantum experiments. The observer effect suggests that the act of observing a quantum event can alter its outcome, an idea that seems to grant the observer a powerful role in determining reality. However, it's essential to clarify that this effect does not imply that human thoughts or awareness influence physical events, but rather that the tools and methods used to measure quantum phenomena can cause changes in those phenomena. Such ideas have led to heated debates about the nature of knowledge and existence. If the properties of the quantum world are so dependent on measurement, what does this say about the objective reality of the universe when it is not being observed? Does reality itself become a subjective experience, shaped by our interactions with it? These questions challenge the very foundations of scientific inquiry, which has traditionally been based on the assumption of an objective, observer-independent reality. Furthermore, quantum entanglement, often described as spooky action at a distance, suggests that particles can become linked, with the state of one instantaneously influencing the state of another, regardless of the distance between them. This phenomenon has implications for our understanding of space and time, suggesting that at a fundamental level, the universe may be deeply interconnected in ways that our human senses cannot perceive. These philosophical explorations are not just academic exercises, they have practical implications as well. They force us to reconsider how we understand information, causality, and connectivity. In the world of technology and communication, for instance, quantum entanglement is the basis for quantum computing and secure quantum encryption, which could revolutionize how we process and protect data. By exploring the implications of quantum mechanics, we are not only expanding our understanding of the physical world, but also challenging ourselves to rethink what we know about the universe and our place in it. Each discovery in quantum physics offers a new lens through which to view the age-old questions of philosophy, providing us with both greater knowledge and deeper mysteries. As we continue to explore these quantum realms, we may find that the answers to some of our biggest questions lie in the smallest particles of the universe. Throughout this exploration of quantum physics, we've uncovered the subtle yet significant ways this foundational science impacts our daily lives. From the technology that powers our devices to the processes that drive our natural world, quantum mechanics is everywhere. It shapes everything from how we toast our bread in the morning to how we use our smartphones and computers throughout the day. This deep, often invisible science plays a visibly and vital role in our everyday experiences, influencing the technology we depend on and even the health treatments we receive. The quantum world may seem distant and abstract, but it is closer and more relevant to our daily lives than we often realize. As we have seen, the principles of quantum physics not only fuel the progress of modern technology, but also provoke profound questions about the nature of reality and our perception of the universe. I invite you to continue exploring the intriguing and mysterious world of quantum physics. there is so much more to discover, and each piece of knowledge we uncover opens new doors to understanding the universe and our place within it. Let's keep questioning, keep exploring, and keep pushing the boundaries of what we know. If you are intrigued by this video and would like to learn more about the secrets of quantum physics, don't forget to like this video and subscribe to the channel. Stay curious, and let's go on this scientific adventure together.